I did.
Did I? Yeah, years ago, 2019.
Alright, where did I put this? Alright, I just need 1 second. Okay, thanks for coming. Just a quick announcement. If you are interested in playing The Intercept, that is a hardware-software network CTF. You've probably seen people with what appears to be Game Boys playing what appears to be Zelda. If you want to do this contest, it is a CTF hacking contest. It's not a video game that you can take home, just for the record. If you want to do this contest, they are having additional signups at 1 p.m., so right after lunch. If you want to do that, go to the Hardware Hacking Village, look for the sign that says The Intercept. Come with a team of 3 to 5 to play. And I would encourage you to go hard because it's a very cool contest. Other than that, after this is the lunch break, so you guys are on your own for lunch, but from 12 to 1 is lunch. And if you have any questions, as always, come ask us at registration or find me. Up next is z0rro and museifu with, I don't know how you want me to say this, to be quite honest, ESXicution. Execution.
That works.
That works. Thank you. Good luck.
Thanks.
All right, thanks for coming out. You want to check your mic real fast?
Yeah, we're good.
All right.
We're good.
Yeah, it's ESXicution. Thanks. Yeah, so we do things and stuff. That is us. Just want to do a quick shout out to some research that's been done, kind of, building off the shoulder of giants here. CMC, shout out to that guy, Injection, and William Lamb, his blog. He actually did quite a bit of work and research in ESXi hypervisors. So a lot of the research that we did is kind of building off that foundation from a system administrator perspective. And then Evasion and Joel GMSec for PyShell that we use in in some of our techniques. So what is this even? Basically, this is a high-level overview of the ESXi operating system from VMware. We're going to walk you through reviewing existing malicious software kits, and then we're going to demo some additional new features that we've built in. You might ask why come to this talk? It's interesting for us. It's a lot of fun. We've used this in the past for things like CCDC. It's also interesting from an attacker's perspective for pen testing and red teaming.
All right, yeah, so what isn't this? We're not going to talk about any CVEs or exploits for ESXi. We're not going to cover gaining initial access to ESXi. We're not going to talk about vCenter or anything outside of ESXi. There's no ODE, there's no guest hypervisor escapes. So really this is kind of classic operating system level, persistent C2, that sort of stuff, but nothing too crazy in regards to CVEs or ODE or anything. So we'll start with what is ESXi. It's a Type 1 bare metal hypervisor, which means that the operating system goes right on the metal, and then is developed by VMware. Comes from the name Elastic Sky X. No clue what that means.
Just some basic terminology. You might be asking, what is a hypervisor? Most people are pretty familiar with VMs, I would assume, but let's just cover it real quick. So a hypervisor is just a operating system that you install on a bare metal server. Like z0rro explained, it runs and manages VMs for you. VMs are just virtual computers that run from a physical computer. There's a layer of abstraction for the hypervisor, for the VMs to sit on top, and they basically share hardware resources, so CPU, memory, disk, and that serves as a layer of abstraction for your underlying VMs. That's it.
So getting back to ESXi specifically, talking about the operating system architecture, the kernel specifically is a microkernel. It's called VM kernel. It used to be based on Linux. It's no longer the case. It's POSIX-ish compliant. It does support binary formats of ELF, so you can take a Linux binary, bring it right over, and run it on the environment. Source code leaked in 2012, so there's probably some more interesting bits kind of sitting in that source code. I haven't seen too many people really dive into the leak at all. Continuing on the architecture, it uses a handful of different file systems. It uses both persistent and non-persistent file systems, so it's a combination of VisorFS, VFAT, and VMFS. And we'll talk about how these are leveraged, but they're kind of intermingled throughout the structure. VisorFS is a non-persistent in-memory file system, so it works as a RAM disk. The ESXi OS stores all of the OS binaries and configuration files in compressed tarballs. So the way that this works is on boot, the ESXi bootloader will go ahead and create a RAM disk in-memory file system. It will then decompress the TGZs and map those files to the RAM disk in memory. Certain changes that are made to some of the files, specifically configuration files, will be automatically backed up. So once the RAM disk is in place and ESXi is fully booted and running, there's a script that will run every hour, and on reboot that will go through and persist any changes you've made to those configuration files. It basically repacks those tarballs. The process is a bit more convoluted than that, but we won't really get into the level of detail there for this talk. It also uses VFAT. This is a persistent file system. These are used generally to store the boot bank. The boot bank is where all those TGZs sit when the operating system is at rest or the host is at rest. There's also a VFAT scratch partition, which is used for the VM kernel that sits there, and then also all of the log files sit on that partition as well. And then lastly, VMFS, another persistent file system. This is used by the VMs for their actual virtual disks and their configuration files. Some of the VFAT partitions actually have symlinks into the VMFS partitions as well.
Yeah, so to talk about management interfaces, so how people interact with these sysadmins, network engineers, stuff like that. You are really interacting with three components mostly. The web UI, so the web GUI, you would log in over HTTP or HTTPS if you have it configured with a certificate. Web API, I have to quickly just make a note here. There has been some libraries that have been written, such as PyVMomi and Python, to kind of interact with that underlying API, perform remote administration over that interface. There's also SSH, which is disabled by default. I think VMware intended this to be more of like a troubleshoot mode, so it's actually called TSM SSH. But yeah, we'll talk about how we use that for our own purposes. Talking about those web services a little bit more. So a reverse proxy is running from the ESXi hypervisor. This is used to route incoming traffic to specific Unix or TCP sockets. And this screenshot is just an example of that. You'll see in a later slide we actually use CGI-bin quite heavily, but host is used pretty frequently as well.
Real quick, just to kind of elaborate on that. So the way this works is when you go to the web UI and you hit different endpoints in the URL bar, you're actually hitting independent TCP or Unix sockets that are being accessed from a reverse proxy. So this comes up a little bit later in a couple of the attack vectors that we use, but it's important to understand that you've got this one reverse proxy sitting on this gateway endpoint, and then it's basically routing the request to the appropriate Unix or TCP sockets. So the screenshot here is a snippet of some of those existing mappings and some of the ones that we'll add to this as well. But if you were to go to /GDP, that traffic will use the reverse HTTP proxy to reroute that traffic to a listener on 8389 in this case. But yeah.
Cool. Talking about some user land bins. So ESXi uses symlinked busybox command. So it basically instead of having like kind of your own shell environment, it's rather than that you basically have just a precompiled busybox binary that brings in all these commands. This list is an example of what is defined by that busybox binary. There is a firewall as well, so have to talk about that a bit in terms of how it pertains to some of the attacks we'll talk about. It's relatively locked down by default. We do need to modify it for doing specific interactions. Yeah, so this is just an example. This screenshot is SSH client. The server and the client are disabled by default. We have enabled SSH server, but the client is still disabled.
So getting into some of the existing kits, we took a look at the existing kits that were out. Obviously, 2022 had headlines regarding a couple of these kits, and it became kind of on the forefront of folks' minds. But we want to talk about some of the more interesting kits that are out there. One of those being a partner kit called Virtual PITA. Virtual PITA was discovered in 2022. It's a binary, 64-bit ELF binary. Once it's running, it provides a bind shell, which gives you upload and download capabilities. It also has the ability to halt logging, so it will stop the sysd process from logging to try to avoid detections. It also has the ability to run commands in the VMs themselves, so from the hypervisor into the guests, but you do need the guest operating system credentials to do that. And kind of the sister kit to that, these are somewhat intermingled as well as Virtual Pi. Virtual Pi is a Python backdoor. It also provides bind and reverse shells with upload-download capabilities. Same thing, it uses the halting of the syslog daemon to stop logging events. Also discovered in 2022, it persists through a script that it drops in etc rc.local. Any of those scripts will run on boot. And the last kind of somewhat interesting kit is ESXi args. It's a Python backdoor, provides a bind shell, gives upload capabilities to the guest VMs, but it's also used for ransomware. And that was kind of a recurring theme as we dug into the kits. We found that a lot of them were just ransomware kits. They were pretty straightforward and pretty basic. They would just come in and they would encrypt the VM hard disks and some of the snapshots. A lot of these kits actually screwed it up, and they wouldn't like delete the snapshots, or they wouldn't pause the VMs or turn them off before they encrypted them. So some of these kits did a pretty bad job, but pretty straightforward. Again, they just come in and encrypt those virtual disks and configurations. But we're not going to talk too much about the ransomware side of things. It's just not all that interesting.
Yeah, so we should talk about one component of ESX. We should talk about VIBs. So VIB stands for vSphere Installation Bundle. It's basically a collection of files that are packed into an archive or a TGZ. So it contains an XML descriptor file, a signature file, and then a file archive. So it's a running state, it's a state of the file system packed into a TGZ. So VIBs are deployed during boot process as modules, so they're kind of similar to kernel modules. You can think about it like that. Have to talk a little bit about that signature file. There are acceptance levels. So there's VMware certified, VMware accepted, partner supported, and community supported. Have to make a note here as well. In previous versions of ESXi, anyone could create a VIB, and you could package it as community supported. I'm going to go over to this next slide and talk a little bit more about that. It used to be you could use a force flag to package your VIB, and then any of your file system changes that you wanted packed into that, obviously. So for things like deployment or for persistence, that's what you could do. VMware has now made it so that without that signature, you can't pack a VIB. So you basically have to be trusted by VMware or basically VMware itself to create VIBs now in ESXi 8.0 plus. But in previous versions, as I said, you could run a force flag to trick the operating system into deploying your VIB with partner level trust.
And real quick, also so the main component of this was so that people could deploy third-party packages into ESXi. An example of this is it was very popular to deploy the IPMI toolset into your hypervisor, so then you could access the IPMI configuration directly. But again, what used to be was anyone could create these tools, they could bundle them up, and you could install it. You have to say, hey, I'm going to allow community, just like unsigned APKs or whatever else. But after all the ransomware hit, it seems like ESXi, they kind of locked it down, and on 8+, you actually cannot install a non-signed VIB. So unless you have the key from VMware, you cannot install that VIB.
That's correct. Another deployment method that we'll talk about is SSH. So again, there is some noise that does generate some warning messages on the web UI, so we'll talk about kind of evasion and ways to kind of go about being sneaky, trying to deploy over the SSH protocol. New deployment methods is something we kind of discovered. This isn't really the intended function of this, but there are config backups. So similar to like a firewall device or something like that, there are running configs. VMware has one for ESXi. You can basically download that and unpack it. In these screenshots on the left, you see the unpacked version of a running config from ESXi. You have this jump start, which is basically, it just contains some instructions at boot time. State.tgz, which is actual running state of the file system at the time that the config was pulled down. So that contains all the file systems. And then manifest.txt as well. Yeah, what we're doing here with this is we're basically going to repackage this. As an attacker, it's interesting to think, hey, what could we do with this state.tgz if we want to add our own files there, maybe SSH backdoor, whatever changes you want to make, and then ship that back up, install that running config after you've modified it. The problem is that state.tgz is it's signed with a key, and yeah, we can't actually modify that and repackage it because we do not have a valid key to repackage that with. So instead, what we can do is supply our own archive. So in this case, on the right, we have evil.tgz. So what happens is we repackage that without the key. We don't need it any longer. We're not going to modify state.tgz. When it gets pushed up to ESXi, we have to set ESXi in maintenance mode. So it's a little, let's say, noisy. Setting ESXi, the hypervisor, in maintenance mode will temporarily halt the running VM, so they have to pause while that config is being uploaded. and pulled in. But assuming we've done that and we're okay with that obvious downtime, the next time that the host reboots naturally, or if we force a reboot if we want, it's going to unpack what's in that running config. It'll unpack state.tgz first, and then our eval.tgz that contains our file system modifications will be unpacked over that. So it'll modify the changes on the file system and overwrite the file system.
All right, so moving on to some existing evasion methods that we've seen from the kits. We really haven't seen too much aside from flat out disabling all of the logging. We've also seen a few of them unset the hiss variable in the bash environment so that any commands that they're shelling out aren't logged. And that's really about it from an evasion perspective that we've seen actively on these kits. So for some new evasion methods, this is very basic, right? Like don't fully disable the syslog daemon. Obviously, the lack of logs in itself flowing into your sim is going to be an indicator. We've seen folks who have alerts just on, hey, I haven't received any data from this endpoint in X amount of time. So opportunistically disabling syslog is good. We've kind of built out a kit that will actively disable the logging system when we take a specific action and then automatically re-enables the logging system. And that will stop that activity from being logged to disk and shipped off to a sim. So again, just an indicator to not completely halt logging.
Yeah, let's talk about other evasion things that we're doing to avoid getting caught. So suppressing UI warnings, right? So again, we talked about if we want to enable that SSH in order to deploy over the SSH protocol, that does cause a warning message. So on the left here, you'll see the warning message from the web GUI, which is pretty noisy. There's a pretty simple command that we could run at the time of deployment to disable that. So that's what you see contrasted on the right. Also, we'll talk a little bit more about this in depth. One of the new features that we're bringing in that we think is interesting, active console snooping. We'll talk about that, just table that for now. What's important to note here is that if we do that, if we want to snoop on an active console session, which I'll explain a little bit better in a later slide, that also causes an alert. If you're a sysadmin, you're interacting with one of your VMs, you don't want to go over RDP, you just want to use the active console session from the browser, great. If another user is also browsing that console session, there is a warning message that pops up. So we've gone through and actually modified this HTML file. There's some JavaScript we've modified to hide that from view.
And again, that's on the ESXi host, right? So because we have root, we can just go in and modify the pages that are being served and the JavaScript that's being served up.
Yeah, and then on the right, it might be a little hard to see, but on the right is an actual browser session after we've acquired a ticket. I'll explain that better in a later slide, but ultimately that is the attacker's session from their own browser.
So persistence from the kit side, from what we've seen as far as existing persistence, obviously the VIBs were the go-to. With 8, that's going to be going away, so I'm sure we'll see some new techniques implemented within these kits. As I mentioned before, any of the scripts inside of etc local.d will run on boot, so you can drop something in there. It does ship with a local.sh bash script in there, so you can just make modifications to the existing script if you don't want to create a new one. And then lastly, cron jobs. So new persistence methods that we've developed and worked on, I'd say new, but really this is just porting over common persistence methods on NIX file systems into ESXi, one of which is backdooring an existing binary, so pulling one of those binaries down, using backdoor factors, hoping to backdoor it, and then uploading it back up and packaging it appropriately. There is a flag that needs to be set in newer versions of ESXi to allow non-signed binaries to run. So this can be run from the command line, and then your backdoored binary will run as normal. Alternatively, you could create a custom module. So a module is a lot like a VIB. It's structured in the same way, it functions in the same way. But I believe the idea here is generally more for configuration changes than it is from a package perspective. But either way, you can create a module. You can set that module into a TGZ, put it in boot bank. Then you modify the boot bank config and you say, hey, on boot, go ahead and unpack this this custom module, and it will overlay those files on the file system. The way the ESXi in-memory RAM disk works is as it goes through the boot config and it unpacks those tarballs and loads them into memory, its order of operations is the first one on the list gets unpacked, second one on the list gets unpacked. If you have duplicate files that exist in 2 of these tarballs, the one that's run latest will overwrite whatever's in that RAM disk. So that way we can do replacement of files and then installation of new files as well. Lastly, or second to last, you can backdoor existing scripts. So plenty of Bash and Python scripts that you can modify for your persistence, and then classic SSH key, right? You can add your additional key to the authorized keys for the root user. So moving into C2 that we've seen on kits, it's again been pretty basic, just bind and reverse shells, bind over TCP bind, reverse over TLS over TCP. We did see one of the kits using that reverse proxy that we talked about earlier to set up a new endpoint behind that proxy. It basically means that they can hit a new / whatever they want in the URL, and that's going to get rerouted to whatever listener they created locally. So we did see one instance of that being used on a kit. So some new features that we've developed, this isn't a direct C2 feature, but basically it's socks over HTTP. So oftentimes on red teaming engagements, we'll come across environments where maybe they have a super restricted network and they're running everything in ESXi, and then they want to allow their admins to access the ESXi interface just over HTTP. So there's a lot of times where the ESXi host will be in a segmented network internal to that network, and the only exposure to that instance is over HTTP. So we wanted to be able to gain access to hosts in that segmented network outside of ESXi, and to do so, we basically created a tool that will run on ESXi that will allow us to proxy traffic in over HTTP. And using the SOCKS protocol, we can encapsulate any TCP connection, send it to ESXi, and then it'll get routed to the destination server behind that host on that segmented network. Excuse me. So this is what it looks like client side. So on your attacker machine, you'll run this client.py. That'll spin up a local SOCKS proxy on your host, so on your operator laptop. And then when you use that local SOCKS proxy, obviously it will take any of the traffic you use through Proxifier or proxy chains. It will wrap that into a SOCKS packet, and then this client-side tool will then take that SOCKS packet and shove it inside of an HTTP packet. That HTTP packet will then get sent up to the server, where server-side on ESXi, we have a listener running. In this case, it's a Python script that's running, and we've already established the mapping for the reverse proxy to come into this listener. So when the client sends the HTTP packet to ESXi receives that packet, removes the HTTP packet portion, takes a look at the SOCKS packet, and then handles the SOCKS packet as it would and routes it to the according host. So below here, we just do a curl, and this is kind of pivoting through the ESXi endpoint. So long story short, once we set this up in place, we can really use that ESXi host to access anything in that environment from a TCP level. We're just going to shuttle all that data over the existing HTTP interface that's been exposed for administrative purposes.
Cool. Yeah, also, again, we have Python environment set up in there, so ESXi comes with Python 3 installed by default. We can take advantage of that, as it's also serving those API endpoints that we talked about earlier. So this is just an example of that. We're setting up a temp directory called cgi-bin that we're going to actually serve our Python pseudo shell from. So that's what's happening here. We basically set up a Python HTTP server serving CGI over that port 8303. And then on the right, you can see we're using PyShell to go ahead and connect over that. And then we have pseudo shell over that HTTP connection. And we basically have code execution at that point, so we can run commands over that.
So this gives us a simulated shell as if we were on that ESXi instance, but again, over that HTTP interface. So we're just, again, tunneling commands over that HTTP interface.
Yep, so some more hypervisor interactions to talk about. Encrypting, so in existing kits, some of the stuff that they're doing, it's pretty rudimentary stuff. It's not that interesting. They are encrypting the VM storage and the configs. It's what most of the ransomware kits do. They're also wiping snapshots, right? So we want to contrast that basically to say that they could be doing a lot more from their vantage point. There's a lot more interesting stuff to kind of rip open and do as far as research. We're going to talk about a few of those new interactions that we can do. So the first one, I talked about this earlier, was the snooping of VM console sessions. To want to break that apart a bit, the console sessions work over this MKS protocol. This stands for mouse, keyboard, screen. This is derived from the X11 protocol. Most importantly, at the time that a person interacts with a VM console session, they are going to be given, or a ticket is going to be generated, and they're going to use that as a form of authentication to that VM console. We have basically taken this and turned it into an interesting attack vector. We've set up a notification in the event that someone interacts with a VM console session. and we're basically shipping that notification over to us. I'll show in the next slide. We'll talk a little bit more about that notification, what we're doing with that, and how we're using it. But this lends itself to an interesting situation, like on a red team engagement, right? Maybe we have a database that we're going after. Maybe we've targeted a database administrator, and so we want to what I'll coin as virtual shoulder surfing. We want to figure out, okay, when is this user interacting with this console session? We know we want to move to that laterally. So using this method, we can shoulder surf off that database administrator. So again, we're getting active notifications when that database administrator interacts with that database server. And we're just shipping that over. Our example is in the first screenshot on the left. This is just an email that we're automatically sending when that database administrator interacts with the console session. We're generating a ticket based on their behavior, based on their action, that we can then use in our own remote browser. We can take that ticket and then pull up the same VM that they are actively on.
We're monitoring one of the log files anytime somebody opens up a console window, so it alerts us and says, hey, some admin's doing something, and we went ahead and just grabbed you a ticket for authentication if you want to check on that session.
Yep. And yeah, you might be asking, is this read-only? It is not. So although we are monitoring, we also have the ability to interact with our hardware, so we can type commands, we can take over the VM if we want with our keyboard. So it'll support all that over that MKS protocol.
And again, the previous masking of that warning message is what comes into play here. So if we connect it into that console session with a ticket for that console, by default, that administrator will get a banner that we saw earlier across the screen saying, hey, someone's in looking at it.
Right, yeah. Yeah, that goes back to the earlier slide about, we can suppress that warning message by modifying some JavaScript in a file to kind of hide our actions and not let them know that we're watching them.
So this one is kind of fun. It's a new hypervisor interaction we came up with or created kind of. So we noticed that oftentimes in red team engagements that folks will join their ESXi host to Active Directory. I originally thought this was just going to be an LDAP bind for authorizing AD creds or authenticating AD creds, but it's not. It's actually a full join to the Kerberos realm. So the ESXi host becomes a principal within that realm. And what that means for us as an attacker is when an administrator signs into ESXi's console through the web UI, a Kerberos ticket granting ticket is actually created for that user and set in the temp directory. So with root access to the ESXi instance, we can just watch the root directory for Kerberos tickets. So on the left here, we've got what the login screen looks like. The center image is there's a Kerberos ticket there. That KRB5 is a Ccache file. So we can copy that back down to our attacker machine, and then once we have that Kerberos ticket granting ticket, we can authenticate as that user within that domain. So on the right hand side, you can see we're just leveraging that ticket, checking to see if it's valid, and then we're connecting to a domain controller in the environment using evil winrm. But what's important to note here is, this is basically saying if we were able to compromise that ESXi host and it's joined to AD, we can sit there and harvest credential data for Active Directory and then authenticate as any of those users at auth to ESXi anywhere within that Active Directory environment. So pivoting away from ESXi and focusing on back into the AD environment using that ticket.
Some other interactions. So we've also set up key logging in a number of areas. So specifically the web login. So again, we've already compromised this ESXi server at this point, and we've gone through and modified some JavaScript files, namely main.js, which appears to have literally everything in it. It's quite ugly. It's horrible to parse too. Don't do it. Trust me. But ultimately, we can figure out where web logins are happening. We can modify that, and in the screenshot, you basically see an example of that. We're just when a user logs in, we're just going to send the username and password as like it'll just generate a log that we can then use. We could ship it to ourselves if we want, that sort of thing. We do that for web user settings as well. So after administrator or a user logs into their ESXi console, they have the ability to modify users, create users, stuff like that. We can keylog all of those entries as well. So in the event that they suspect something is up and they want to roll the root creds for the device, we can log that as well. More interesting an attack kind of a interaction is console sessions. So again, going back to those console sessions, obviously we can snoop on them. We can use the snooping method we talked about, but we can also just keylog the keyboard keys that are entered into those VMs as well, and ship those over. So you'll see in the output, this is a screenshot of a VM being interacted with, and then the console keys, those are basically the key characters that need to be transcribed at a later time into their ASCII representation. Another thing to talk about is memory dumping. Normal function as an administrator on ESXi is to create snapshots. Unfortunately, a lot of people think that's the same thing as backups. It's not. Don't do that. But ultimately, a snapshot is just a place in memory where we're taking a snapshot, quite literally, of the running state of the VM. In the event that you want to perform like an update or an upgrade, if something goes wrong, you can easily roll back. That's, I think, really the intended purpose. We can utilize this as an attacker, so we'll talk about that. In this step, we're creating a snapshot of a running VM. We're going to download that, download a couple files, so the vmem file and the vmsn file. The vmsn is used to store the exact state of the virtual machine when a snapshot was taken, like we talked about, and the vmem is a backup of the virtual machine's paging file. We'll talk about what we'll do with that next. So we can go ahead and dump that. We're going to use, this is actually a proprietary VMware binary, VMSS2 core. We can use that to convert those files into a core dump file. And then we can load that core dump file into WinDBG, and then load mimilib. So not the full mimikatz, we're not going to run the full binary, but we'll load mimilib.dll into WinDBG and use that to go ahead and carve out the LSAS process. So there's a section of memory within that core dump file. We're going to target the offset for the LSAS process, and then Bob's your uncle. We're going to run mimikatz and dump out the secrets from that. And then once we have those secrets, again, you can use your favorite protocols. WinRM, for instance, is what we've used with that.
So an important note here is we've seen that I don't know of any EDR to date that supports ESXi. I think it's something we're probably going to see maybe in the near future, but right now there really isn't any. So on engagements, it's easy. If we compromise one of these instances and we get on there, you're kind of just roaming free. You can do whatever you want. But more importantly, with root access to all the VMs that are running, we can now create these snapshots, and we can do things like LSAS dumps that are completely invisible to EDR running on those VMs. So we can. It doesn't just stop at LSAS. We can extract SAM files. We can do anything really. But the idea here is we're a layer outside of the software. So we're outside on the hardware layer. EDR is not going to see any of this. So it allows us to do LSAS dumping, grab prived creds, and not really set any kind of alerts off right now as it stands right now.
So other than extracting secrets, obviously that is useful. Other than interacting with proprietary Windows protocols like WinRM, RDP, stuff like that, we can also just use those guest credentials at that point to interface with that API that we talked about earlier. So we can use PyVMomi in its entirety to run basically remote execution. So we're running. We're basically popping calc on a VM using those stolen guest creds. One note here, actually two notes. This does require the guest VM creds, as I said, and it does require VMware tools to be installed. So that is a dependency in order to interact with that API call. But we're doing this from our Kali machine to the VM itself. One other note, this will spawn child processes under the VMware tools process itself. So any process that we spawn would be child processes of that.
And I know we gave a shout out earlier to PyVMomi, but if anyone is interested in starting to play with any of this stuff, especially at the API level, that library is probably the best place you can get started with all of this.
Yeah, agreed. A couple other interactions. We do see this in existing kits. File upload to VM and file download from VM. Again, this requires guest VM credentials and VMware tools to be installed. This is just an example of us uploading a file to a VM from our attacker's machine. So it's going to interact with through that API through the hypervisor, and then go ahead and upload it directly to the desktop of the VM. We also have a download. I don't have a screenshot of it, but we have a download that, funny enough, there's a package of PyVMomi pre-built. This is an example upload file to VM. I had to write my own and download from the VM and then do some crazy transcribing, but you can do it.
Yeah, so lastly, we wanted to take some of the time that we have to map some of these attack vectors to MITRE, right? As an attacker, it's important to take a look at these attack vectors in a structured and documented manner. So we wanted to make sure that we're kind of looking at this holistic view and saying, okay, as we're walking through the chain, where is this lining up and meeting industry standards? So we're going to take a minute to go through all the attacks and how they tie into the corresponding MITRE attacks. Just kidding, that shit's whack.
Cool. Yeah, so that's our talk. I think we probably have some time.
Yeah, we
for
got plenty of time
questions.
for questions if anyone has any questions.
Yeah, or if you want to come up and talk to us after, we'll be around all weekend, so feel free. Love talking about this shit, so.
Any questions? Yeah.
So the DIV, for everyone's terminology, there's the user community maintained packages. How exactly did there was like a signing bypass that you guys were describing earlier sometime. How does that work like specifically? Because if there is a signature, is there just like an oracle where you can send the package and sign it?
Yeah. So previously, before A, the way that it worked was there were multiple levels from like, hey, this is from VMware, this is a partner of VMware, this is a community VIB. Oh yeah, sorry. The question was, how did the VIB structure work, and how did the quote-unquote bypass function as far as getting that malicious VIB installed previously? Was it signed? Did you bypass signing? So the way that it worked, especially on the virtual PITA and the virtual Pi kits on the older versions of ESXi, so you have these tiers, and I think the only one, maybe one or two that are open to the community, our community and something else. But basically, when you want to install those community VIBs, you have to go into the UI and you have to say accept, third-party VIBs that aren't signed. So what we were seeing happening is folks on these older kits, they were modifying their descriptor XML. So the descriptor XML actually said that it was a community-supported VIB, meaning it was like signed by VMware, but it wasn't. There was no signature there. So then they had to drop to the command line and they had to use a force flag to install it as a purely community VIB. So basically saying like, hey, this isn't signed. We're going to force the install. But when it shows up in the UI, because they made that modification to the XML, it actually shows it as a VMware supported VIB, which is kind of interesting. So they didn't really bypass anything. They just used a supported feature, which was to force install the VIB at the open community level. And the only real trickery that they did was they went in and they just modified the XML file to say that it was a partner-supported VIB. So then in the UI, it showed up as a partner-supported VIB. So you used to be able to go in and just force these VIBs in with the force flag once you allowed community VIBs, and that's changed with 8. Now you can't do that at all. But there wasn't really any kind of signature bypass. It was just forcing the install of a community VIB and making it look like a partner VIB in the UI.
Right.
You can install it. There is no signature check. You can write in the command line. And then you just hit XML, so when the web front end processing, it shows VMware.
Yeah, exactly. Yeah, and the XML file, you modify that when you create the VIB, so prior to the deployment of it. But any additional questions?
Yeah, good question. Anything else? Otherwise, we could probably go to lunch early if you guys want. So.
Yeah, I think we're good. Thanks, everyone. Oh, sorry. What?
One more generic also. So the gist of this getting is, as far as like privilege escalation or open exploitation countermeasures, we're still stuck in the 90s as far as this is concerned.
Yeah, I mean, the OS environment there's nothing really there. I mean, so what we're seeing now is a lot of people are relying on shipping those, the syslog daemon logs out to their SIM and then triggering off of that. But now with the latest version of ESXi, we're also seeing restrictions on what can be installed, and then it feels like they're kind of just trying to limit how you can deploy stuff and lock things down. And I think that's what we're going to see at first, is we're going to see more restrictions on non-signed binaries. Can they run, can they not run non-signed VIBs? Can you install them, can you not install them? But yeah, as far as the operating system itself and security goes, back to the 90s, yeah.
And then as far as the remote attack surface is concerned, there's an SA server, there's a web server, there's some kind of web API. If you're not going to single credentials, like just, I know it's not something that you're talking about, the kinds of exploits that have been developed against this, like, how do I phrase this diplomatically? How shitty are they? Like, as far as exploitation against external hackers, not malicious cyber, as far as how good is that?
I'm sorry, was the question how good is the patching of those CVEs or those exploits? Was the question how good is the remediation around those exploits that's come out from VM?
How much external hardening is there? If you're not just scaling credentials, you're actually trying to develop no data.
Yeah.
What you're seeing, how
Yeah, I think. Oh, good.
Yeah, I can take this. So generally, this would not be deployed like on the edge. You would generally deploy this only internal. I hope I'm understanding your question correctly. So you would generally install your ESXi layer, definitely well behind your. Ideally, you would only interface it with it over like a jump box, and you would have proper, go figure, network segmentation. Not that anyone has that. And then yeah, you would only interact with the interface.
The web API.
The web API
and the web
from
UI.
that jump box, or SSH if you want to interact with it over SSH. Yeah, you're more than welcome to administrate however you want. But ideally, yeah, you're protecting it by setting it up in your network with layers of protection before, you know.
Okay, so in other words, if someone wanted to get onto this thing via the web interface, typically speaking, there's not very advantageous to have one server side where the interface is screwed.
Well, yeah, I mean, it depends. I haven't looked. I'm sure there's probably some 2FA modules out there you can intertwine it with. I haven't looked to see if the web UI supports that. Probably does to some extent. But yeah, you're at the mercy of the web auth, right? So
Yeah.
if we can get creds for that web login, then you're screwed. So if the question is, how secure is this in itself if you only expose the HTTP endpoint? As secure as those creds are. So we've done engagements where we found EXSI creds.txt on a file share, and we've done other ones where we had to inject into the Chrome browser, dump the credential storage, and we found it in their Chrome browser, right? So we usually will hunt the ESXi admins to try to get that credential data, and then move over to the host and properly authenticate as an admin.
Yeah, there's one more note I should make here that it was outside the scope of this talk, but there is vCenter, and the way that you would usually deploy this or configure this in your environment is you would have vCenter as like your orchestration for all your cluster of ESXi hypervisors. And so you could configure it in such a way that you don't even need to interact with ESXi. You never need to administrate it remotely. And so that could be an indicator, right? Like if attackers are specifically targeting ESXi, well, I never touch ESXi because I administrate it from this layer above, this vCenter server. It is outside our talk, but that's one way you could do that.
Yeah, there's quite a bit more to this ecosystem we didn't touch on. This is kind of as direct as you can get to the hypervisor layer. But everything from like the vSphere API to vCenter, there's a lot more there to kind of scratch at and look
For sure.
at. So.
Yeah.
Cool. Any additional questions for us? Okay, awesome. Well, enjoy lunch, everyone. Thanks for coming today.
Thank you.
All right, that's the last talk before lunch. Everyone enjoy lunch. Next talk in here will be 1 o'clock.